talked about as far as moles are concerned, like the connection between moles and bulk volume. I'm sorry, bulk mass. So molarity actually connects moles with volume because it's the units for molarity are moles over liters. And this also is connected to mass as well because it's the moles of what we call the solute over liters of solvent. All right. So when we think about molarity, moles of solute can easily be derived from grams of solute, right? If we know the molar mass of what's being dissolved. And so when we talk about molarity, it's another way to connect moles with some physical uh, manifestation, like a liquid, a solution containing a certain number of moles of a compound, so on and so forth. So we're going to, in this section, we're going to be talking about properties of solutions. We're going to talk about concentration, which is we're going to, when we start talking about molarity and how to determine it, that's where the idea of concentration comes in. And you'll see the symbol for molarity is uppercase M. And then we'll be talking about dilution, how to take a solution of known concentration and then dilute it up or down to a new solution with a different concentration and a different volume. So and normally you'll see this dilution equation written. You probably saw this when you took chemistry in high school. M1 V1 equals M2 V2. Depending on which book you're using, you might see it written as C1 V1 equals C2 V2. All right, so both the big M and the C are both concentration. Right, both of those are used to indicate concentration. All right, so let's start out talking about solutions and talk about what a solution is. We've actually encountered this already when we were talking about matter and different states of matter and different types of matter. We talked about pure substances, and then we talked about compounds and elements, and then we talked about mixtures. And a solution is a type of mixture, right? So a solution is actually a homogeneous mixture. Right, so homogeneous mixture. And what we know about solutions is that they are, if it's homogeneous, that means that it's uniform all the way through. And I mentioned this morning to the morning class that if I had a solution of sugar, I took sugar and dissolved it up in water, right? And I took out a 5 milliliter sample, and I took out another 5 milliliter sample and another five, and so I took out 3 samples, all of the same volume. Each one of those samples is going to have the exact same amount of sugar dissolved in it, because one of the key features of a solution is that it's a homogeneous mixture. So it has uniform composition throughout, right? So the way that we look at solutions is we think of them as concentrated. That's how we think of the composition of a solution. It's either going to be concentrated or it's going to be dilute, right? So solutions have a concentration what we call a concentration, which is literally what we call the molarity. So big M. And again, that's moles of solute over liters of solution. Moles of solute over liters of solution. Let me fix this up here. So I put solvent. And I don't want to indicate that because the solvent by itself is a component of the solution. But once you mix the two components, the solute and the solvent, then it becomes a homogeneous mixture. And that's important when we think about using concentration to calculate different pieces, right? Whether we're looking for moles or volume or concentration or grams or whatever. So every solution is made up of a solvent and a solute. The solute is what's being dissolved. And the solvent is what's doing the dissolving. So this is the medium. It's the medium for dissolving. Right, by medium, it's just the thing in which the solution, the solvent and solute come together to become the solution, right? So I mentioned this to the earlier class, like the medium would be like if you were making ramen noodles. The water is the medium, and then when you take the little flavor packet and put it into the water and get it dissolved up, that's the solute. So the medium is the place where the dissolving happens, and the solute is what's being dissolved in that thing, right? I said place, but I mean, what I'm trying to say is a thing. So some liquid where your solute is being dissolved, all right? And then you can characterize a solution as being dilute or concentrated. And I'm abbreviating solutions as SOLNS, right? It's just a way to abbreviate it. So dilute or concentrated. Those are the two characterizations for a solution. If it's dilute, that means that there's not much solute in the solvent. Right? And if it's concentrated, it's the opposite. More solute per solvent. All right. So with that being said, let's jump right in and start talking about concentration and molarity and solution. So this is how we measure solution concentration through a concept that we know as molarity. And we again express that as uppercase M, and that is again moles of solute over liters of solvent. That's always going to be the way we express concentration. Moles of solute over liters of solvent, right? And typically, when we're dealing with concentration type problems, we're either going to be given a specific number of moles and a volume to calculate the molarity. We're going to be given grams and a volume to calculate the molarity, or we'll be given molarity and volume to calculate the moles. because you can manipulate this in multiple ways. So it'll be molarity times the volume would be moles, right? Moles over molarity will give you volume. Right? And again, you can take this and manipulate it however. You know, molarity is moles per volume per liter. Molarity times volume will give you moles, and then moles over molarity will give you volume. So these are the ways in which we can manipulate this relationship to find different terms. If we have any two terms, we can find the third term. All right, so let's jump in with an example. All right, and this is, we're gonna take a 375 milliliter. Make sure you pay attention to the units. If you don't put your concentration in moles over liter, your number is not going to come out right. Your calculation is going to be off, way off, by the way, because if we get milliliters, and they're supposed to be in liters, right? That's 1,000. A milliliter is 1,000th of a liter. So it's going to throw your calculations off. So make sure when you're calculating molarity that you take heed to the unit. So this is molarity, it's moles over liters, always, right? So we got a 375 milliliter solution that contains 0.266 moles of solute. All right, this is the most basic concentration example that we could do. We have the moles and the volume, and we want to figure out the concentration. Right, when you hear the word concentration, we also call that the molarity. So those are interchangeable terms. So when you see a question on the test or a quiz that asks for the molarity, it's asking you for the concentration, the number of moles per liter, number of moles of solute per liter of solution. All right. So this is what we're calculating. Moles of solute over liters of solution. What do we have to do in order to get this calculation? In order to do this calculation, we have moles. Moles is fine. We won't have a problem with that. We got a problem with our volume though, don't we? The volume is given in what? Right? The volume is given in milliliters, but we need it to be in liters. So we need to first convert the volume. So convert the volume from milliliters to liters. How do we do that? What's the conversion from a milliliter to a liter? And is that number going to go up or down? In other words, is the number going to get bigger or smaller when you go from milliliters to liters? Think back to when we were doing conversions. Anybody? When we talked about doing conversions, one of the things that we learned was anytime you're going from a smaller unit to a larger unit, the value of the number is going to decrease, right? So this is going to be 0.375 liters, right? We go from a smaller unit to a bigger unit, the number is always going to get smaller. And vice versa. You go from a bigger unit to a smaller unit, the number is going to get bigger. All right, so that's our volume. Now we just need to calculate the molarity by taking the number of moles, 0.266. Somebody go ahead and be calculating that. Moles divided by 0.375 liters. What do we have?
I got 0.709.
We'll take that. And then the unit, when we calculate concentration, it's just M. We write it as 0.79 M, but when we say the concentration, we say that it's 0.709 molar. Right? So the big M, we say that that's the molarity. And the way we describe the solution is that it's a 0.709 molar solution. Right? Because one of the things that you'll see when you're working problems is that it'll give you the concentration, but it'll just say it'll show you the M or it'll say molar, 0.709 molar. That's understood to be 0.709 moles per every 1 liter. Right, so that's what that's what this means. This is 0.709 moles per 1 liter. That's what that big M stands for. All right. Well, I can do better than that. Take advantage of this technology since it'll draw a straight line for you. Somewhat straight anyway. All right. So you'll see that referred to as a 0.709 molar solution. All right, let's do a couple more examples. Let's jump to another example. But in this example, we're going to be given the molarity and the volume, and we need to figure out how many moles it is. So if we have a solution that is 0.375 molar, and the question is how much solute is dissolved in 10 milliliters. All right, so we got the concentration, and remember the relationship, M equals moles over moles of solute over liters of solution. So how are we going to get moles? And I neglected to put that in here. How much solute? I should have put it in here in moles. Is dissolved in 10 milliliters of solution. All right. How do we do that? If we're looking for moles and we have moles over liters, how are we going to manipulate that relationship to solve for moles?
Would it be liters times the big M?
Yeah, so it would be big M times liters, right, or volume equals moles. So that's how we're going to solve for it. We have the molarity. So the molarity times the volume will give us moles. We have the molarity, so 0.375 moles per liter times 10 milliliters. Now we got a problem there, right? Because if the molarity is moles per liter, we need our volume to be in what? It needed to be in liters. So how are we going to convert milliliters to liters? What do we do? I'm just going to do it all in the same pocket. So we got 10 mils times what? 1 liter over. This is our conversion from milliliters to liters. You need to, we should already have it memorized, but this is one you can't like do without, because you're going to see this forever. Right? So that if we do that conversion, that will give us 0.010 liters. .010 liters. So now we can just multiply those two together, and that'll give us the number of moles. So what do you have? 0.375 times 0.010. Don't break the microphones now. Clog up the internet with answers. Does anybody have this as the answer? Yes, no. I know spring break is looming. That's a good question, Christine. I sent a list out of students who are coming in person and students who are virtual for today. So check the announcement for lab, and if your name is not on that list, then you'll be streaming. All right. Did anybody get this calculation? 0.04004? All right, cool. All right. Now let's take this a step further, because there's some stuff that we already know. And this is a way that you'll see this question. You'll see questions like this, because it's not always going to be cut and dry, like, hey, here are the moles, here's the solution concentration. Tell me this, tell me that. What if the solution was, let's see, chromium, what if it was a solution of chromium-3 bromide? Let's ask this question. How many, this is a legit question, how many grams of chromium-3 chloride were used to make the solution? I said chloride, but I meant bromide. What would your approach be to this question?
Would you break it down first?
Elaborate on that. I agree. We're gonna have to break something down. But what's the, so we're looking for grams, right? We have moles. The moles we just solved for. What relationship can we exploit to find out the number of grams if we have the number of moles already? I think you own something. Was that you, Brian?
Yeah, but you just lost me.
Is it molar mass?
Molar mass. If we know the molar mass, we can figure out how many grams of anything we have if we have the number of moles. Because remember, we can use the molar mass, right? Which is what? Grams per what? Mole. So if we know the number of moles and we're looking for grams, we can manipulate this relationship and say that molar mass times moles will give us grams. All right, that's good. We're on the right track. Now, if that's the case, how do we get the molar mass?
That's when you break it down, right?
Mm-hmm. So what do we need to know? We need to know what the formula is, don't we? And
Yeah.
it's given to us in word form, but we got to write it out with the right subscripts so we can know exactly how many atoms of chromium there are, how many atoms of bromine there are. So what is the symbol for chromium? We need the molecular formula. Chromium is here, and it's telling us that it's chromium 3, right? That's what the, even though it's kind of sloppy looking, that's what the Roman numeral 3 in parentheses indicates. That is chromium 3 plus. And what's the charge on bromine? It's group 7. Anybody remember that from that list of ions that we were looking at when we were putting these compounds together? Bromine should have a charge of what?
Is it -3?
No, you're thinking about nitrogen. Bromine is -1. Anything in group 7, all your halogens have a -1 charge. So then when we put this together, this is what? Chromium 3 bromide. That's what it looks like. All right, so now we need to figure out what the molar mass is, right? We got 1 chromium. Can somebody look that up on the periodic table? And we got 3 bromine. Bromine is 79. So that'd be 3 times 79. And then what is chromium? Anybody?
You look for the molar mass, right, sir?
Yes, the atomic mass or molar mass, yes, of bromine.
51.9961. So I guess you could put 52.0.
You said 9961. Let's go with yeah, let's do that. Let's do 52. And this is grams per mole. This is also grams per mole. You see how all this stuff is connected? That's why it's important to get the basics. Once you learn the basics, you can apply them to something a little bit more complex. So 3 times 79, what's that going to be? Close to 240. What is that?
237.
37. So 237 grams per mole. And over here, 52 grams per mole. What is that? 289. Is that right?
Yes, sir.
That's the molar mass of chromium 3 bromide. All right, so we're good. We're good to go now. We can solve this. So now we can just take the number of moles up top, which was 0.004, which we already calculated. .004 moles times 289 grams per mole. Right, moles are going to cancel and we'll be left with grams as our unit. Somebody hit that real quick for me, that calculation.
What is the 289 multiplied by, sir?
The number of moles we calculated initially, 0.004.
It's 1.156.
1.156 grams. All right. So when the way this works, let's say, and I said this to the class this morning, I'm gonna say it to y'all. Let's say that you're a TA in a lab and you're asked to make a solution of chromium 3 bromide, and you have the little bottle of chromium 3 bromide, and you're asked to make a 250 milliliter solution. What you're doing there is you're taking a volumetric flask, which is a very precise piece of glassware where you can measure up to 250 mils. They make 1 liter volumetric flask. 10 mil, 50 mil, so on and so forth. You take that, you weigh out your chromium 3 bromide onto a piece of weight paper or weight boat, put it in the flask, and then add the water to bring it up to 250, right? It's that simple. That's how you make solutions. But in order to make solutions, you got to know how to use molarity and how to figure out how much of the solute you actually have to dissolve up in the solvent to get the solution, all right? So we solve for moles, but then if we know what the solute is, we can also figure out how many grams we need. All right, let's do another one. Let's take, any questions about that before we move on, by the way? Let me not just rush. I'm not rushing because we still got 10 minutes left. Right, but do you see how all the stuff that we just learned in the previous section, we can still tie it into this? You never lose that. So you always want to keep practicing and touching on it to make sure that you're familiar with it, because you're going to see it. I said that when we first started doing compounds and naming, you're going to see that stuff from now all the way through your chemistry life until you're done with chemistry. So it's good to have a good grasp of it. All right, let's do another example. This is our third example. All right, and let's say we have a solution of cobalt 2 chloride, right? And we have 6.52 grams of it. And we've dissolved that up in 75 milliliters of water. All right, what is the molarity? What's the molarity, right? How do we calculate the molarity from grams of cobalt chloride? You see that? Cobalt 2 chloride, by the way. Remember, molarity is what? Moles of solute over what?
Liters.
Liters of solution, right? So how are we going to get moles from what we have? Can we do the same thing we just did?
I think so, yes.
Yeah, we have the chemical formula. We have the number of grams. From the chemical formula, we can determine the molar mass. So let's do what we just did. So we need to first convert grams to moles, right? And we do that through by, in this case, grams over molar mass will be moles, right? So we're going to take 6.52 grams divided by the molar mass of cobalt 2 chloride. Okay? And we can figure that out. Somebody look up cobalt on the periodic table.
The molar mass of cobalt is 58.93.
58.93, and that's grams per mole. And then chlorine is 35.35, but it's two of them. That's going to be 70.70. And this is also in grams per mole. We just need to add these two numbers together, right? And that's going to be 129.63 grams per mole. So now we just plug that back in, right? So once we get that number, the molar mass, we have grams, boom, we're just going to put it right back together, divide by 129.63 grams. Oh, what do we get?
0.05.
0.05 moles. Highlight that. Right? We got our moles. Now we need our liters. But right now, our volume is in milliliters. So we need to convert that. How many liters is 75 milliliters? So it's going to be 0.075 liters. All right, now all we need to do is put them together. So the molarity is 0.05 moles divided by 0.075 liters. Any questions about that? Y'all quiet today. Somebody pop that into the calculator and tell me what you got.
Got 0.6 repeating.
0.6. Yeah, so we're going to say 0.6. Or let's say 0.67 molar. All right, that's good. So all we're doing now is manipulating the equation of moles per liter. And then using relationships we already know. We know how to get moles from grams if we know the molar mass. We know how to get grams from molar mass and moles. We know all of that already. All right, so now I'm going to end like I ended this morning. I'm going to put lunch on the line, or late lunch, or dinner, whatever you want to use it for. But I'm going to put a question. We got 4 minutes left, so you got 4 minutes to solve it. And I'm going to put a question similar to the one we just did. All right, the question is, how many grams of calcium chloride? We're going to help you a little. 110.98 grams per mole. Right? Are contained in 250 milliliters of a 0.2 molar solution. You got 4 minutes, and the first person to give me the answer, I'm buying lunch or dinner, whatever, because it's almost 2 o'clock. So you probably already had lunch. All right, let me give you some work. Huh?
I get the steps mixed up every time, so I'm gonna pass on this one.
That's all right. That's all right. We're gonna get the answer. So don't go back to what we just did and use that process. Look at what you have. You always want to ask, what do I have? What do I need? I have a molar mass. I have a concentration, and I also have a volume. Right? So I can figure out the grams if I know the relationship between those things. All right. So we're gonna say 3 minutes. Let me give you some working music. Let me go back and pull up some of my old stuff, Dusties.